Hello, my name is Christian Bishop, and welcome to my presentation on IPv4 subnetting. Today we will dive into the fundamental concepts of subnetting, its importance, and practical applications in network design. What is subnetting? Subnetting is the process of dividing a large network into smaller, more manageable networks. Why would someone use or implement subnet? Uh, Subnetting can improve network performance by reducing broadcast domains. We minimize network congestion and improve overall performance, as well as bringing some enhanced security by isolating sensitive data within specific subnets. Enhances security and reduces the attack surface. Efficient IP address allocation. By allocating IP addresses more efficiently, we can conserve IP addresses and reduce the need for future readdressing. Finally, it can help simplify network management by smaller, more well-defined subnets. They're easier to manage, troubleshoot, and scale. To understand subnet masks, a subnet mask is a 32-bit number that defines the network and host portions of an IP address. So 192.168.1.100, just about what everybody sees. These first three sets of numbers you should be very, very familiar with, as well as the 255 going across. It's apologize. It's there's a binary format as well, which is it's 24 bits represented in ones, and that can be seen as the network portion, and the last 8 bits of that 24 or that last set is zeros, which represent the host portion. Classful versus classless addressing. Traditional classful addressing is a traditional method with fixed network and host address sizes. It's divided into A, B, C, with each of their own having specific network and host ranges, and it's usually inefficient IP address allocation, especially for smaller networks. Whereas classless addresses the limitations of classful with introducing Cedar. Cedar allows for more flexible allocation of IP addresses by using variable length subnet masks, also known as VLSM. With this, networks can be divided into smaller subnets of varying sizes, leading to more efficient utilization of IP address space, as well as it facilitates routing and reduces routing table size. Subnetting techniques. Usually there's a conversion from the address to binary, whereas here's an example here. Determining subnets and hosts, you would count the number of network bits and host bits in the subnet mask. To calculate the number of subnets, you would use a formula here, and then calculate the number of hosts per subnet. There's this formula here, and out below I have outlined a example. VLSM is pretty efficient. It allows for the use of different subnet masks within a single network, and it just allocates IP addresses pretty efficiently. Some benefits would be customized subnet sizes to match specific network requirements, reduce IP address wastage, and just overall improve network security by isolating different network segments. I have a scenario outlined here with a network department requiring different number of hosts. Here you would need a sales department needing 100 and an IT needing 20. So in that scenario, you would use 24 subnet for sales and then 27 subnet for IT. To continue on, we will cover supernetting, which is the combining of multiple smaller networks into a single larger network. It has multitude of benefits like simplifying routing table entries. It reduces routing protocol traffic, and overall improves routing convergence time. I have an example would just be combining those two networks, 24 and 22, into a single network. Common issues with subnetting. A lot of the time, there's overlapping subnets or incorrect subnet masks. The overlapping can lead to two or more subnets shared on the same network address, and that can lead to routing issues and packet loss. Incorrect subnets would be, using an incorrect subnet mask can result in the network and host address calculation, just leading to connectivity problems and routing issues. Some tools you can use would be like ping, and traceroute. Ping checks the basic connectivity between devices, and then traceroute traces the path of a network or through a network. Some key takeaways would be, subnetting is a fundamental network concept for efficient IP address allocation and network management. Understanding subnet masks like VLSM and supernetting is crucial for network design, as well as troubleshooting subnet issues requires careful analysis and use of appropriate tools. In conclusion, I've gone over the fundamental concepts of IPv4 subnetting, including subnet masks, VLSM, and supernetting. Accompanied by efficiently, dividing a network into smaller subnets, they can optimize network performance, enhance security, and efficiently allocate IP addresses. Understanding how to calculate subnet masks, determine the number of subnets and hosts, and troubleshoot common subnetting issues is crucial for network administrators. As technology continues to evolve, it is essential to stay up to date with the latest networking trends and best practices. By mastering this art, of subnetting, you can design and manage efficient and secure networks for your company. Thank you.